Hi all, welcome to Greenboard. So today we are going to discuss exercise 1.3. In previous videos we have already covered exercise 1.1 and 1.2. So before going to exercise questions, there are some words which we have to get familiar with. So let's move on. So the first word which we are going to familiar with today is the term subsets. Okay, what does the term subsets mean? Okay, we have already know we are already using the terms like subgroup, sub inspector of police, otherwise sub district, sub collector, etc. So what does this sub means? In sub inspector, what is the position of a sub inspector? An inspector that comes just below the inspector, that is sub inspector. Sub inspector comes just below the inspector, as well as sub collector comes just below the collector. The position of sub collector is just below the collector, as well as we have already used the terms like subconscious. What is that? A level of mind which is and another level of mind like conscious, that is more correct, I think. Okay, as well as subgroup, we know subgroup, isn't it? Subgroup means a group which is under a group, isn't it? That is a subgroup, a group which is divided further into small groups. Okay, similarly subset means a set within the set, that is the definition too. Okay, a set which is within a set is called subset. Okay, so subset is also a set, but it comes under a set. Okay, we will first define a set and all the sets, otherwise all the small sets which we can write from that set, it represents subsets. Okay, so let's look at this first photo. This first photo represents the family photo of a family. Yeah. It is a photo wall of a family. So it consists of by assuming from this photo, we think we can understand that, otherwise we can assume that this will be their family photo, isn't it? That means that family consists of father, mother and two daughters, as like father, mother, an elder sister and a younger sister. Okay, that is their family. By what which by evaluating this photo wall, we can think that this is their family. Maybe there are more members, but by seeing this photo, what is we can understand is this represents their family. Okay, so all these photos are the combinations of different types of combinations of people in that family, isn't it? This the first one represents not the first one, the second one represents the whole family, so it will be their universal set because all the members of that family are represented in that photo. So the second one comes as the universal set of their family, so it is also a set, isn't it? That's why they included that picture in this photo wall. Also comes the first one. What is that? A wife and a husband, otherwise a father and mother of that family. Okay, so it is also a set. Only two members of this family are included in this set, but we can understand that since these two members also belongs to that family, we can say that this photo represents a subset of this set. It is the entire universal set consists of four family members, and the subset consists of two family members. And who are they? They are the father and mother of that family. Okay, then comes the third one, which is the daughters and wife, or otherwise mom and daughters, mom and children. Then comes the siblings only. Okay, two siblings. Then comes dad and children. Okay, father and children are then the other combination. So all these represents some types of combinations of people representing that family, or the people including in that family. So all are subsets of this big photo, otherwise this whole family group. Okay, so this represents a subset. Okay, these all are 1 2 3 4 and 5 represents a subset. Okay, for a subset there are two conditions that is followed every time. Okay, the first condition is the universal set is always a subset. Okay, the universal set itself comes as a subset of every set. So from which set, otherwise the entire set, that is more correct, I think. The entire set is always a subset. When from a universal set we will represent a set. Okay, and from that set we are writing the subsets, and the entire set comes as a subset of itself. Okay, the set which we are considering is a subset of itself. So this whole family photo is a subset of itself. Okay, so how many subsets will be here? 1 2 3 4 and 5. Actually 1 2 3 and 4 are the subsets, but by this condition the entire set itself comes as a subset. We can tell that this is also a subset. So 1 2 3 4 and 5, there are 5 subsets here. And the second condition is the null set is a subset. Okay, null set is a subset of every set. Okay, all set has null set as a subset. So this is the null set, isn't it? This blank space can be considered as a null set. Since null set is an empty set, so this blank space is an empty set. So this is a set that represents 1, then 2, 3, 4, 5 and 6. So from this photo we can count 6 subsets. Okay, there are 6 subsets for this family. Okay, and all these subsets are the all the subsets that can be made from this family photo is included here? No, because we can take individual photos, isn't it? There are many family photo walls that represents individual photos of that family members, isn't it? So we can take the photo of mother only, also the photo of dad only, as well as the photo of elder sister only, also younger sister only. So 4 individual photos also can be placed here, there and here, there also, isn't it? So there are no such a combination. So this is not an entire subset that can be built from this photo. Okay, this represents only some subsets that can be built from this photo. This is not an entire subset. Okay, the collection, now we are going to understand the one more term, that is power set. Okay, the collection of all subsets that can be made from a set is called power set. Okay, then the group will attain a power. Okay, if all the individuals come alone, as well as if all the types of subsets can be considered, then it attains. Okay, we can understand it in such a way. Okay, more childish way, I think. Then the group attains a power. Okay, if everybody come together, that attains a power. That's why it is called power set. Okay, so all the subsets that can be made from a set, collection of all the subsets that can be made from a set, it is the power set. Okay, so this here father only, mother only, elder daughter only, younger daughter only. Okay, then comes the 4 sets, subsets. Then father wife, otherwise father mother, then father elder sister, father younger sister, then finished. Okay, then mother elder sister, mother younger sister, then 2 siblings, then 3, the group of 3 and the group of 4. Okay, so all the group consisting of 1 member, all the group consisting of 2 members, all the photos, otherwise groups consisting of 3 and then 4. Okay, and also the null set that represents a power set. Okay, then it has an equation. We will get familiar with otherwise I will tell now itself. Okay, so all the, now we told that all power set consists of all the subset that can be made from a set. Okay, so here how many members are there, or our entire set consists of how many members? 1 2 3 and 4, isn't it? There are 4 members in our actual set. So the number of people that can be made, otherwise the number of subsets, otherwise the elements, number of elements in a power set is 2 raised to n. That is the equation. So the 2 to the power of how many members are there in a group. Okay, so here there are 4 members, so 2 raised to 4, that means 16. Okay, so 16 type of subsets can be made from this photo. Okay, that's the meaning of that set. Okay, then we are going to familiarize with one more term, that is proper set. Okay, we already proper set, proper subset, that is more good. Okay, proper subset. What is a subset? We understood it already. That is a set which can be made from a set, or a set within a set, that is a subset. So how what is mean by proper? We use the word proper in sentences like follow rules properly, wear uniform properly, go in a proper way. Okay, that are the proper terms that which we use, proper sentences which we use casually, isn't it? Proper way, in a proper way, wear uniform properly, proper uniform, isn't it? So proper means what? In a right way. That's more good, I think. In a right way, that is the term proper means. Okay, so what is a proper subset? A subset which is a subset, that a set which is a subset in a proper way, otherwise a set which is a subset in a right way. We told that since a subset is a set within itself, by that sentence meaning we can't include this set. That means the entire set as a subset, isn't it? Because it represents every members of that set, and it does not represents actually a set which is within that set, isn't it? So this is an exceptional case, but still we are including the case of null set. So accepting the entire set, all the subsets that can be made from a set except the entire set, that represents the proper set. Okay, proper subset. So when we told the number of power set is in number of elements in a power set, we told that it is 2 raised to n, isn't it? So from that, for a proper set we are expecting that we are accepting one term from that, or otherwise one member from that, which is that this entire set. Then how many members will be the 2 raised to n minus 1, since we ignored this photo. So the number of proper subsets of a set is 2 raised to n minus 1. So how many will be here? We told that there will be 16, since there are 4 members, 2 raised to 4, that is 16. So from that 16 we are excluding this photo. Then what happens? 16 minus 1, that means 15. So there will be 15 subsets for this set. Okay, so 2 raised to n minus 1, here 2 raised to 4 minus 1. Okay, now let's move on to this picture, then it will become more clear to you. Otherwise we are going to repeat the same things here also, so that you will understand it more thoroughly, I think. Okay, so this is a dining table, and there are many dishes and plates placed on this table. Also there are 4 seats for 4 family members to sit down. Okay, so whatever dish they took from this dining table and put it in their plate, that plate will represent a subset of set of all dishes on this table, isn't it? If they only took the dishes from this dining table, okay, we are accepting the case that one can go and take it from the kitchen, otherwise one can go and buy it from a shop. Okay, we are accepting that case. And what will be the all the subsets, or otherwise all the food items any people eat, okay, from this dining table. Okay, so somebody will take 2 chapatis, somebody will take a spoon of biryani, otherwise. Okay, likewise. Okay, so all the plates will represent the set of a subset. Okay, a subset of set of all dishes on this table. Also the plates are also a subset. Okay, and this entire table itself a subset, as well as we will always consider a null set case also. So in actual way, the food which we are bringing to our school, our lunch box, otherwise the food which we are eating with our plate, within our plate in our home, or what all these represents, it is a subset of the collection of food in our home, isn't it? Usually we bring food, lunch to our school from our home, so that lunch box is a subset of a collection of food in our home. Some students will take food from school itself. School will provide food for some students. So what that represents, it is their food and their plate represents the collection, is a subset of collection of food in their school. Okay, that's what we are eating. Okay, it's a collection. It is a subset of collection of food which we have made in our house. Okay, and then the power set represents all count how many foods are there. Okay, from this picture you can see two plates of gulab jamun, isn't it? But we have to consider only one, because we know that in a set there is no repetition. Also there are three plates representing chapatis, but we have to consider only one case, isn't it? Because only there is no repetition. Okay, so one gulab jam, one chapati, then this plate I think there are two, so that only one we are considering. Then this plate is two, that only we are considering. Then this is sauce, I think there are two plates of sauce, but we are only considering one. Okay, similarly by taking that one cases, okay, only one element from each common thing. Okay, then 2 to the power of n. N means how many type of dishes are there, that represents the power set. Okay, and what is the proper subset? Excepting the case of this entire dining table, how many subsets will be there? Excepting the case of this entire dining table, how many subsets will be there? That represents the proper subset. Okay, so these are the things which we have discussed today. What are they? Subset come under universal set. The entire set and null set are always subsets. Okay, so a non-empty set will contains at least two subset. Okay, a non-empty set means what will be there? At least one element, so that one element and a null set, so there comes two. So in a non-empty set will contain at least two subsets. The number of subsets increases as the number of elements in a set increases. Okay, and then what is power set? Collection of subsets. Okay, collection of all subsets, that is power set. Okay, the number of elements in a power set is 2 raised to n. So number of proper subset is 2 raised to n minus 1. In that minus 1, which is that one which we excluded from 2 raised to n, that is the entire set itself. Okay, accepting the case of one the entire set, how many numbers will be there? That represents the proper subset. Okay, now these all represents some of the examples of subsets as well as proper subsets as well as proper subsets, which we can tell that also. Okay, so this is a soup that is made of corn and fruits. Okay, so the corn soup is this. So how many corns are there? That each corn grain represents a set, as well as the combination of two corn grains, three corn grains, etc. And also all the groups. Okay, all the rows also and all the columns also represents different subsets. Okay, since each corn grain have different shape, which we can't by that we can't represent it as a single group. If we are representing it as a corn group, it will be considered as one. Okay, so that represents a subsets. Okay, the plate is a subset, the spoon also have to be there. Okay, then it will become proper subset. Since there is no spoon, it is only a collection of subsets. Okay, also here this is a fruit salad bowl, a bowl consisting of fruit salad. So the bowl, the spoon, different types of fruits. Okay, all these represents different type of set. Also this is a stem. Okay, so the stems as well as the leaves all represents different subsets. If all the leaves are represented here, then it will become a power set. Okay, if for photo only they represented some subsets, it will become a subset, collection of subset only. But all the leaves, if all the leaves are represented here, it will become a collection, it will become a power set. Okay, if we accepted this photo, then this will become the proper subset also. Okay, from this it is a pair of photo, and if we excluded this photo, then this set will become the proper subset. Okay, also and this entire photo, a pair of this full photo represents the power set. Okay, because in power set there should be a universal set. Okay, so this entire photo, this entire pair of photos represent a power set, as well as this is a photo of people resting in a ground. Okay, they are resting in a lawn. So the collection of all umbrellas, collection of mats, collection of people, their carpets, etc., all represents different type of substance. If all these are included, all the members, all the accessories are included, then it represents a power set, including this photo also. This represents a power set. If for photo they only represented some of them, then it will become a collection of subset. Okay, then now let's move on to exercise questions. Okay, this is the symbol of subset and this is the symbol of not a subset. Okay, so now let's go to the questions. 2 3 4 is a subset of 1 2 3 4 5. Is it right or wrong? Okay, so 2, this is 2 and we can see 2 here. 3 and 4 is also here 2. So 2 3 4 comes under this set 1 2 3 4 5. So 2 3 4 is a subset of 1 2 3 4 and 5. Okay, also A B C, but here A is missing, so A B C is not a subset of B C D. If it has to be a subset of this set, A should also come here, because in a subset a set is within a set, so all the members of a subset should come under the set, but since here A is missing, it is not a subset. And comes the next one. What is that? Set of all X such that X is a student of class +1 of our school, and set of all X such that X is a student of our school. Definitely a student of class +1 is a student of their school, so it is a subset. And also there is one more term which we have to familiarize. Okay, that is the we told that a subset is a set which comes within a set, and that big set is called superset and the small set is called subset. Okay, subset which we have understood, and superset is the set from which that subset is built. Okay, so here we told that 2 3 4 is a subset of 1 2 3 4 5. Otherwise what we can tell, 1 2 3 4 5 is a superset of 4 3 2. Okay, also here student of your school is a superset of student of class +1. Okay, these are the answers of that. Superset is represented in light green. Okay, the reverse symbol of subset, that is superset. And what is the next one? Set of all X such that X is a collection in a circle in a plane. Okay, so X represents the circle which we can draw in a plane, and the next set is what? It is a circle which have only radius 1. So collection of circle will contain circles of different sizes, otherwise different radius. It will have circles with radius 1 centimeter, 2 centimeter, 3 centimeter and so on, but the set that comes on the right hand side only have circles that have radius 1, so it is not a subset. If it have written in reverse form, that was right. So collection of set of all X such that X is a circle is a superset of collection of circles with radius 1. Here in question it is represented that we have to write only subset and not a subset, so the answer is written in the blank space. And since I have to introduce you the term superset also, I written the superset symbol under the blank space. Okay, the answer of this question is written on the blank space, and the superset representation is only written on the written on under the space below the blank space. And what is the next question? Set of all X such that X is a triangle in plane. Okay, and set of all X such that X is a rectangle in plane. But the triangle and rectangle has no connection, isn't it? So definitely it is not a subset, and we can't make any superset also from there, so it is only a not a subset of. And comes the next one. Set of all X such that X is an equilateral triangle in plane. So this collection represents triangles with equal sides. See, 3 equal sides. And what is the next one? Set of all triangle in a plane. So equilateral triangle comes under all types of triangles, so it will be a subset. Otherwise, how we can tell all types of triangle is a superset of equilateral triangle? Okay, then comes the next one, set of all x such that x is an even natural number, and the next one, it is an integer. So integer consists of all the negative numbers, 0 and positive numbers, and even natural numbers consist of only 2, 4, 6, 8, 10 and so on. So even natural number is a small set that comes under a big set, which is the collection of integers. So definitely even natural number is a subset of collection of integers. Otherwise, how we can tell it? Set of all integers is a superset of collection of even natural numbers. Okay. Then examine whether the following statements are true or false. Okay, here one more thing I have to note. Okay, the term superset should be read from here. Okay, normally in a question we will read from here, but here for this answer we have to read it from right to left, because the only intention of the superset symbol is to make you introduce with that term. Okay, that's why I wrote it here. Then comes the next question, examine whether the statements are true or false. There are 6 statements and we have to check whether they are true or false. Okay, set AB is not a subset of BCA, but look, A comes in two sets and B is also present in 2 sides, then it is a subset, isn't it? So that is wrong. And AE is a subset of collection of vowels. What is a collection of vowel? A, E, I, O and U. So A, E is a subset of A, E, I, O, U. Then so it is true. And comes the next one, 1, 2, 3 is a subset of 1, 3, 5. But 2 is present here. Here there is no 2. So it is wrong. Third one is wrong. And set A is a collection subset of set ABC. That's right. And set A is not an element of set ABC. Okay, if they told us a element of ABC is right, but set A, when set comes, it is a subset, isn't it? Otherwise we will write only the elements. Here the set notation comes, it will be a subset only, then set A can't be a element of set ABC, so it's wrong. And set of all x such that x is a natural, even natural number less than 6, so what will be the 2, 4. And comes the next one, set of all x such that x is a natural number which divides 36. What will be the 1, 2, 4, 9 and so on, 6, 9 and so on. So sixth one is true. Okay, when you don't understand by seeing it in a set builder form, just write it in roster form and then it will be more easy for you. Then comes the next question, we have to find which all are incorrect and have to state why. So we are excluding the first row. Okay, that means 1, 2 and 3 for some time, we will discuss it last. Okay, then comes the fourth one, 1 is an element of A. In A there is 1, 2, 5 in normal case, and there is also a set within that A. What is the 1, 2, 5 and set 3, 4. Okay, so 1 is an element of A, it is true. And one subset of A, if it should be a set subset, it should first come as a set, and for a set there will be set notation, but for one there is no set notation. So fifth one is definitely wrong. Whether one belongs it or not, for to become it as a subset there should be curly brackets. Since the curly brackets are missing, definitely we can tell that it is wrong. Okay, then comes 1, 2, 5. 1, 2, 5 has set notation, so it is a subset of A. We can see 1, 2, 5 in A, so 1, 2, 5 is a subset of A. Then set 1, 2, 5 is an element of A. That is wrong, because 1, 2, 5 are only the members of A. So when they told us 1, 2, 5 element of A, that will be correct, but here set 1, 2, 5 is a subset of A, not element. Okay, so the seventh one is wrong. and set 1 2 3, that is wrong because 3 is an exceptional case. Okay, then 8th one is wrong. And 5, we know that 5 is not an element of A. Okay, 5 is not an element of A. If 5 is an element of A, what will become? And the set will be an empty set. Okay, otherwise that 5 should represent Greek alphabet 5, but a Greek alphabet is missing in the set A since A consists of only numbers. So the 9th one is wrong. And 5 is a subset of A, that is correct. Okay, every set has a one subset. What is it? 5. So 5 is a subset, otherwise the empty set is a subset of every set. So 5 is a subset of A, but it is not an element of every set. Okay, then comes set 5. We have already told in previous video that when we write set 5, it represents the Greek alphabet psi. If 5, okay, when we have to represent an empty set, we have to write either the null curly brackets or the 5. We don't have to write, we should not write both together, then it will represent the Greek alphabet 5. So definitely the 11th one is wrong. Okay, then we are going to first 3 ones. Okay, set 1 3 is a subset of A, that's wrong because set 3 4 is an element of A. Okay, in 1 2 and 3 only 2 and 3 are correct and 1 is wrong. Okay, here 3 and 4 have two set notations. So set 3 4 is an element of A, and set 3 4 set of set 3 4 is a subset of A. So 1 is wrong and 2 3 are correct. Okay, answers I have already written here, what are correct and what are incorrect. Okay, then comes the next one. Write all the subsets of B set. Okay, so first one is A. So what all we can write? We know that first we have to write the two conditions of subset. Okay, first fill that, otherwise you will forget it. So the entire set itself, that means set A, and null set are sets, subsets of every set. So we have to write first the entire set and null set. Since there are no other elements, only we will get two elements, so it's over. And comes the next one. What is the set AB? So the entire set, so set AB, and the null set, so the null set. And we have to write how many subsets which we can write from that. First write one by one, then write with two groups, and write with three groups, and so on. So one group means set A alone and set B alone. Then comes 2 with 2 members, but already the 2 members are there in group, then their set is written, so there will be 4 members. Okay, we know an equation for power set, isn't it? Power set have only 2 raised to n elements. Here set AB contains only 2 elements, so 2 raised to n here means 2 raised to 2, that means 4. So there will be only 4 subsets, and we have written there 1 2 3 and 4. Okay, then comes the next one, 1 2 3. Okay, so 1 2 3 means there will be 3 elements, so 2 raised to 3 is 8. So we will get 8 elements in a power set. Okay, so the entire set, that means 1 2 3 and null set, so null set. So we have written two subsets which we forget more easily, that we write first. Okay, so now let us write each member one by one. So set 1, set 2 and set 3. Now we are going to write each set 2 by 2. Okay, by writing it in 2. Okay, so 1 2 and 1 3, then with 2 first. Okay, 2 1 and 2 3, but 2 1 we don't have to write since we already written 1 2, because in a set there is no order and repetition. Then 2 3 we wrote, and then comes 3 1 and 3 2, but 3 1 and 1 3 are same, also 3 2 and 2 3 are same, so we have already wrote there, so we are not going to write it one more time. Okay, then comes a collection with 3, but which we have already wrote it there. Okay, so the collection set is finished. So 1 2 3 4 5 6 7 and 8, there are 8 elements. Okay, then comes P of A. We will write P of A means power set. Okay, collection of power set. If A is a null set, if A equal to 5, what will be P of A? A equal to 5 means A is a null set, otherwise an empty set, so there will not be any elements, so number of elements will be 0. That means power cells equation is 2 raised to n. So here n is 0. So 2 raised to 0. We know that any number with the power 0 will be 1. So 2 raised to 0 is equal to 1. So if an element is, if a set is empty, it will have one element, that will be the null set. Okay. Now we are going to familiarize the term interval. Okay, there are four types of intervals which we should definitely know. So let's first understand them, and then we can go to exercise questions. Okay, then it will become over 18. Okay, this will be the last question. Yeah. So first we have to understand what is an interval. So we are going to understand what does the term interval means. Okay, usually in interval, okay, in set case we are going to understand four terms. They are less than or equal to, greater than or equal to. Okay, first let's understand it in a simple way. Later we can go to mathematics term. Okay, consider this as an ice cream. Okay, I am going to draw an ice cream. Okay, this is an ice cream. Okay, we have already tasted it. Okay, we know what an ice cream means. Okay, so in an ice cream the scoops will be placed on the top, isn't it? They will place one scoop, then place the next one, and place the third one usually. Okay, so when we eat an ice cream, the entire part of ice cream will be, entire part is wrong, I think. The major part of ice cream comes on the upper side. Okay, here comes the major part of ice cream, and those part of ice cream that melts down and come here will we get when we reach there. Okay, the major part we will taste here, and only we will get some parts when it come here. Also the area is also less, isn't it? Only in an ice cream there is only this side have more space, so definitely this side will have more ice cream. Okay, because this side can hold me large part of ice cream, because here there is more space. But here it is a, since it is a cone, here there is only a point. So since there is less space, only a small amount of ice cream can hold here. So while eating an ice cream, this part gives us more ice cream, and here we will get less ice cream. Consider now the ice cream has fallen. Okay, ice cream fall down, otherwise we kept it in this position. Okay, so how will it be? This part have more ice cream, because this part is the bigger part, and here there will be less ice cream. Okay, similar in the case of what it is, in this case of less than symbol. Okay, consider this as a, yeah, these all are ice cream. Okay. These are ice cream. Okay, so since this part have large ice cream, I have to write the bigger number here. When I write 8 here, this should be the largest one. So what should come here? Since major part of ice cream is 8 grams, then here only comes a small grams, then it should be 4, 5, 7, and so on. Okay, when I write 10 here only should come 9, 8, 7, etc. Otherwise when I write 20 here there is an option for 19.9, otherwise 19.99, but should not come 20. Okay, so while writing it's in mathematical form, we are we are ignoring this ice cream. Okay, we are only drawing its cone. That's what actually happening there. We can understand it in such a way. So how should it come? If 3, 4, 20, 100, 11, 1 this then here comes 1. Okay, if it is the symbol, how can we write it in the next form? If 3 is small, okay, so here comes 4, 5, 6 and so on. Okay, here 1 is small, so here 2. Here 100 should be small because 100 is the smallest part, so here can come 200. Okay, here 20, so here 25. Similarly, okay, now let's go to complete mathematical form. Okay, these are the pairs of symbols I have written, and now we are going to mark symbols in between. Okay, how can we mark 3 and 4? So ice cream should fall in this way, isn't it? Because 4 is the largest part, so 4 should come there. So the greater side should come there. Then here 7 and 9, so greater side should come there. Okay, when it is 122, it is 111 and 122, what will happen? 111 is the bigger side, so it should come this way, here like this and this. I think this is understood now and no need of writing it more, I think so. That's why I am stopping here. Okay, so this is the way which we have to write. And when we are writing it in an interval form, there an interval should consist of two numbers. Okay, two or three, yeah, two numbers is good now. Mm. When we are writing an interval, if we are including the two limits of our interval, okay, that means we can write any number that's from 2 to 5, including 2 and 5, we will represent it in this way. Okay, this is 2 and 5 including 2 and 5. When we are writing 7 and 9, but we can't write when we are including a side, we should represent it in square bracket. Okay, it means I am including 9 but I am not including 7, then I have to write normal bracket. Okay, I am including 4 but not including 41. Now I am not including any these limits. Okay, so what does the first one represents? 2 and 5 are included, so I can write 2 and 5. But here 7 is not included, that means I can write from 7.1, otherwise from 7.01, but I can't write 7. Okay, but I can write 8.9, also 9. Okay, here 6 I can write, 6.1 I can write, but I can't write 5.9 because I start only from 6. Also I can't write 41.01. Also 41 I can't write. I can write only up to 3 point, otherwise 39.9, otherwise 39.99. Okay. Similarly here I can't write both the limits. I can write from 10.1 to 19.99. Okay. I think you guys are familiar with it now. Now let's move on to exercise. Okay, first we are going to understand this second one, that is more good, I think. Minus 3 and 0. Oh, sorry, first second one you can't write now. First we have to discuss. Okay, so minus for less than or equal to. Okay, when less than or equal to comes, what it means? Less than, and otherwise it should be an equal, that means 6 can also write there. Okay, so minus 4 is not included, so we will write normal bracket there, and 6 is included, so we will write square bracket. Here 0 is less than or equal to, so 0 can be equal, so 0 is included, so we'll write square bracket, and 7 is not included, so open bracket. Here minus 12 and minus 10 both are not included, since there exists only less than. If they are no less than or equal to, otherwise greater than or equal to, we can write them. Here it is less than only, so minus 12 and minus 10 are not included, so both we will write open bracket. Okay, then comes the next one, 3 and 4 both are included, so we will write square brackets. Okay, then comes the next one, all the intervals set builder form. This much is same for everyone. Okay, set of all x such that x belongs to R. Okay, this only the numbers vary. So the first one is 6 and 12 are included, so less than or equal to. Okay, in this form it will come 6 less than or equal to x less than or equal to 12. Here 6 is not included and 12 is included. Since 12 is included, there comes less than or equal to. 6 is not included, so less than. Here minus 23 and 25. Okay, minus 23 is included, so minus 23 less than or equal to, but 5 is not included, so less than. Okay, then minus 3 and 0. Minus 3 and 0 both are not included, so both has less than. Okay, answers are written here. Then comes the next one, what universal set or sets would you propose for each of the following? Either we can write a single set or we can write two sets for each of them. Okay, so the set of right triangles and set of isosceles triangles both will come under the set of all triangles, right? So we have to write only one set. Okay, a universal set, what it is? The set of all triangles. Then comes the next one, there is given set A, B and C, and we have to write which all universal set or sets can be taken for each of them. Okay, in set A 1, 3 and 5 is included, and here in first option 0 to 6, so there comes 1, 3 and 5, so 1 can be considered as a universal set of A. Okay, then for B 2 for 6 comes, so B can be considered as a 1 can be considered as a universal set for B. Then C 0 2 for 6 8, but 0 is there but 8 is not there, so for C 1 is not a universal set. Okay, then comes 5. 5 is an empty set, but A, B, C are not empty sets, so we can't write. Then comes 0 to 10, so there will be A, B and C, so for both of them 3 can be chosen, and for the fourth one there is 0 missing, so except C, A and B can be included in the fourth one. So universal sets for A, B and C are written here. Okay, so that's all for today. This was a lengthy video. There is 46 minutes now. I am taking videos in this way because I think this is more good for you, because you can, when you watch one video, there will be entire exercise questions of that set. If I took it part by part, I thought it will be difficult. So if you guys are watching it, you can pause and watch it later also, isn't it? That's why I am making it in this way. But when we go to next chapters, we can't do this. Okay, because there will be more number of questions in each chapter. So in my possible way, I will take it in this way, whether it will be lengthy or short, since you can stop and watch it later. I thought this will be more easy for you, that's why I am taking video in this side, this style. Okay, so thank you for watching. That's all for today. Thank you for watching Green Box.